What really separates problem that requires foundational infrastructure, a new layer, a new thinking, versus just another tool in the stack?
All of those companies that you mentioned are all observability layer companies. Part of this, I guess, is because I feel that pain acutely. And I'm like, this makes my life suck. And I want something to help on that. As that layer has gotten easier to use through Databricks, more and more has kind of come up. And you're like, wow, okay, now we got these data pipes, we got the logic layer, we got all this stuff. Who's keeping an eye on this? And that's where stuff really kind of breaks.
What prompted you and Great Point to be part of our journey?
No, I was saying, I've known Matei and the whole team since the beginning of Spark days. And so I've always been a huge fan of that. And I've also been super frustrated with it because I'm always like, man, this is so difficult. How do I see stuff? Like, what's that observability tier? There's a complexity thing that's coming. And I don't think people realize how big the complexity argument is going to get. It's spaghetti times some exponential that's coming with the AI stacks.
Hey everyone, and welcome to another episode of Data Innovators. Today's a really special episode for me. I'm hosting DJ Patil, one of the OGs and early pioneers of the data space. DJ helped define the role of the data scientist, led data and product at eBay and PayPal, and later on at LinkedIn during its hypergrowth years, working on everything from large-scale recommendation system to early foundations and infrastructure like Kafka. He also is the author of Building Data Science Teams and Data Jiu-Jitsu, and went on to become the first chief data scientist of the United States under President Obama. So today, or for the past few years, I've been an advisor and an investor, previously with the Great Point Ventures, and he's a recent investor in Definity. He's backing some of the most important or innovative companies in data and infrastructure, and we're honored to have him on our roster. So DJ, thanks so much for joining us today, and excited to dive in.
Yeah, thanks for having me. I mean, it's a special treat for me because I'm honestly such a big fan of what you and Definity team have built and created. And I'm always like, these are the kind of products where I'm like, man, I wish I had that. That's exactly the kind of stuff I want.
Yeah, that's exactly what we said. So maybe let's back up. I don't know, that like 10, 12 years, 15 years ago. You worked obviously across industries, government, now investing. If you compress the journey on the data side, what are one of the two experiences that kind of most shape how you think about data systems today and kind of where we're going next?
Yeah, the first, like, there's probably three or four that are sort of seminal markers for me. The first one, honestly, was grad school. And that was when we was trying to work on this idea of how chaotic the weather is, what could be predicted, what couldn't be predicted, kind of all these different components. And then in that process, that's when data was just first really showing up at scale on the web. And that was primarily weather. And so using that what we might classically call data mining, and then sort of bridging that into using some lightweight algorithms, just because there wasn't a lot of compute available at that time to do things with that big amounts of data. But that then translated into, after 9/11 happened, saying, hey, how do we take those similar ideas and put that into national security? How do you find the signal in the noise kind of efforts? And so then it was the first time I said, oh, wait, okay, I'm doing this in weather and classic fluid dynamics. Now I'm applying it in national security. And then when I moved out to the Bay Area after that first federal stint, then it was like, wait a second, this is a problem for all consumer internet companies, all enterprise internet companies dealing with fraud, abuse, security, those type of things. And so we showed that very quickly that if you shared data between eBay and PayPal, you could really knock down fraud rates. And then it was like, well, why can't this be a product that is more user facing? Why does it have to be a back end thing? And that really led to LinkedIn and saying, well, what does a data product actually look like? What could you actually have a full product that goes to the end customer? What does that look like? And those became the things like who viewed my profile, the talent matching algorithms, recommend you for a job, all those pieces. all these kind of components started to pull together. And you saw this happening everywhere else, whether it was the back end sides for ad targeting, whether it was shopping recommendations. You started to see stuff in dating sites. All these kind of things started to be forward moving. And then, of course, naturally taking that then forward into both the enterprise and starting Relate IQ, and then again into the federal government, where it was like, hey, why aren't we using data to really help people in novel ways? And that includes like the creation of the largest data set humans have ever created around the human genome, medical history, all those things to try to find new treatments, new styles. Like you got a data takes a long time to collect. Doing things there, doing things on national security side, doing things on like helping on cancer patients, all these areas. We realize like data is fundamental to that, and much of what you see happening around AI and healthcare, the underpinnings of that are really around these efforts. That was our efforts during that administration. And then similarly, writing the first U.S. national strategy around AI, automation, all of those components to try to set the country on the right trajectory for these things. But those would, and then of course now, but then again, doing it in healthcare again, and actually the care models for take care of people, because I think we have this honest question we have to ask ourselves, which is, big data has done amazing things for the healthcare system. So long as you're a payer or a hospital, it's done very little for you as a patient. And so the question is, how do we actually make sure that data, AI, all these things are actually going to benefit the real person that needs the care?
All right, so it's not like you took very similar mental models and very different application across verticals and domains.
I mean, data science is a horizontal in many ways. And so you can apply it to all these different things. I mean, you see this on the definity side is, hey, if you got data pipes, at the end of the day, your data pipes are kind of the same. They kind of look like, it's like there's some nuances obviously to all those flows. But at the end of the day, the problem set of complexity, the management, the observability, they're all the same. It's the same thing at the end of the day. It's not like we use a different computing system for one thing or the other unless it's super specialized. So same kind of approaches, I would say.
Previously spoke with Renu Tiwari, who used to lead platform at LinkedIn, and obviously you were there for a long time, much earlier on. And you kind of talk just now about how over time the mental model stayed relatively similar. Obviously, scale grew significantly. So let's talk about LinkedIn for a second. How was the mental model around failure? I think Renu said before it wasn't an edge case; it was a constant. How did it evolve when the system scale? How did the team actually try to handle it, and why do teams still struggle to get real, ability to detect issues, root cause issues, identify them before they happen, even today?
Well, I think part of the thing is LinkedIn was at that time interval where things were just starting to merge, that this was a thing. So this is still very much a time pre-cloud. This is still rack and stack. This is still Java stack. This is pre-Hadoop. This is MySQL just starting out. And many of the things that, we take for granted now, they didn't exist. This is pre-mobile. This is still BlackBerry era. So it's kind of hard to believe what was taking place at the time. But what we saw, and this is pre-Datadog, like the cutting edge innovation at the time was Splunk. So, you still had to like just even monitoring or basic uptime management of the data centers, all these things, that was still really hard. You had network operations command, your NOC kind of layer, and you had kind of traditional teams, you had to SSH into each box and do all this stuff. Like there was a bunch of data science that was being applied to things. And we were like, hey, you know what? We need to double down on that. And so that's where we just had to honestly invent a lot of technology. And that first layer of technology really was around the traditional faster databases, could be key value stores. There was a Dynamo out of Amazon. Ours was Voldemort. And then like when we said we need to move around,
Thought you cannot name it, but
Exactly. Well, it was like a big thing around Harry Potter names at the time. That tells you the era this was. Which is not a great SEO strategy when you're competing against Harry
Yeah.
Potter names and themes. But that's also why Kafka got invented at LinkedIn, because we couldn't afford the costs of Splunk. And we said, how are we going to manage this? We couldn't afford Informatica, couldn't afford Oracle. And so you had to come up with these new models. And so we invented Kafka as a way to kind of look at the logs, diagnose problems, understand what's happening, but also you need it for data products because you need that data to move very quickly. Similarly, like we had to have these databases on the data warehouse side. That was like the traditional data warehouse model was getting democratized. And so that turned into Greenplum, Aster Data, Vertica, and then sort of was like, oh, wait, we're going to go for the Hadoop era, the cloud eras, the MapRs, all these things, that kind of frame. And there wasn't a lot of tech around that. It had to all be built out. And then, like one of the things that is there is you have design trade-offs and challenges of supporting things. So Kafka is that kind of log layer analysis, but it doesn't have logic really built into it at that time. It was really
Hmm.
kind of analysis layer. And so you need a logic layer. We always intended it. That was always by design in there because you at some point you want to kind of be more stream processing esque. And then that's when similarly you were seeing stuff emerge out of Berkeley's AMP Lab and other groups. And that's where you kind of saw Spark first emerge, was like, hey, you need a logic layer. And we were like, this is great. These worlds were all bubbling up. Everything was kind of moving at the same time because we're all dealing with the same problems. And so, and that I think is where we first saw the same time when we were finally realizing, oh, there's a new job title. We called it data scientist, and that took off. And then we were like, but there's more than that. And it took us several more years, maybe 3 more years to realize like, oh, there's this thing called data engineering that's very specialized in its own way before everyone was owned data engineering pipelines. So that then emerged into, okay, well, what tools do they need? Because we have DevOps for the other stuff. What is DevOps for the data engineer? And I think as your evidence of this, we still kind of suck at it. Like we don't have a lot of tooling there. And it's about, I'm sure we're going to talk about this, it's about to get a heck of a lot worse than given what's coming up on the AI side.
So with this imminent threat, let's pause just for a second. We'll still focus a little bit on the past, and then we'll keep going on that thread. But if I go back to those hyperscale times and even today, right, there is a constant tension between performance, reliability, cost. You just talked about tooling cost, but overall platform. Um, where do you see organization get this wrong today? What are they missing, or what are they doing after the fact or not baked into their day to day that is then causing them pay much more later on?
Yeah. So it's a really good question. And everything that I've been fortunate enough, lucky enough to be around, um, every single thing is like design trade-offs. And I know there's a set of decisions. I'm like, I'm gonna regret this one. Or, and it could be regret because I'm putting it in. It could be regret because I'm not putting it in. And I'm like, what I'm trying to always assess is where is the risk curve for these things? And so some technologies you need to be bleeding edge, like absolute bleeding edge. And other ones you just need to be a little further back. So in the case of LinkedIn, one of the things that was very convinced of is that we had lots of great product ideas. We didn't have the technology to execute on them. The
Mhm.
technology did not have the ability to scale. And so, we tried that first. We were first on traditional Oracle, and you can't build a people you may know kind of module on that technology. It's just not possible. Then we built it, on first on Greenplum, then on Aster, and then we finally figured out, oh, you scale it on Hadoop, and now there's a lot of other choices that you can use. But back then, it couldn't do it. Um, so what then you realize is, okay, that means that we're going to have to take this big bet on Hadoop. That's a big, bold bet. And it's like, we're about to become committers kind of level. Kafka. You're inventing your own technology by definition. It took like 3 years before Kafka was truly baked enough to be what you might call certified or trusted by LinkedIn operations team. Took a long time to get them to be like, this has all the components we need to be there. And by that time, you're like, yeah, but this is pretty much a company because it's so robust and everyone's using it. The same way I think you saw that with some of the Spark stuff and Databricks kind of component. So the part that then I think is there, like, and the flip of this is like in healthcare, you don't want to be that bleeding edge. You want to be actually a couple steps back because, like, not only the regulatory environment, but you need stuff to be a lot more stable. In consumer land, you need it to be really go go go. And you're kind of seeing a similar thing play out in the AI space right now. But look, one of the things I think though in trade-offs is, what do I expect to get for this? And in our case, when I'm looking at these data things, I'm looking at the data to be one side net saving opportunities, but the other side is I'm trying to have it open up new territory, like new thinking, new ideas, new product, new innovation lanes. Like I'm really, really interested in how do we make sure that that's going to take place, because that's what then it becomes the engine that powers everything else. And if you don't do it that way, your talent is kind of locked in. And this is what you see in organizations where they're very reliant on contractors, especially around data engineering. You're never going to get the innovation out of that data pipeline. The innovation kind of starts all the way at that movement transport layer of data all the way through. And you have to have a touch and feel for that data that's really unique, and you can't abstract it away.
Yeah, we see, I think we see that very, very intently today, where really innovative team in their field are really focused on the domain expertise to understand, knowing the data because they know the domain, they know the business logic, they know the demands. This is where a lot of the knowledge is coming in today. Something maybe it's harder to replace versus trying to potentially reinvent the wheel, or being a little bit more in the infra layer where, again, and we'll touch a little bit on your touch in those areas, but like very good tooling or layers today that are becoming available.
Absolutely. I think that's really well said.
So touching that, obviously you were personally invested, I would say, both as an investor and probably emotionally with a few of those very foundational
Yeah.
technology, and anywhere from Figma to Confluent to Monte Carlo to Chronosphere, and of course today Definity. Before we even touch on Definity a little deeper, if you look at it, so we talked about again those type of tools or infrastructure layer, like what really separates a problem that requires foundational infrastructure, a new layer, a new thinking, versus just another tool in the stack that, again, I think we all want to potentially move away from the modern data stack and proliferation of too many tools to handle.
Yeah. So, like I think part of like all of those companies that you mentioned are all observability layer companies, right? And part of this, I guess, is because I feel that pain acutely, and I'm like this makes my life suck, and I want something to help on this. I need something here. And like, I remember seeing Datadog at its first startup pitch. My office mate, the person who was next door to me, Michael Callahan, he actually joined the board of it. I was dumb enough not to say, please let me invest. But then, as Datadog came up, you realize, oh, there's this thing is like, people are getting really frustrated with the cost, the structure, a bunch of those things, and that created room for Chronosphere. And then they realize, like, oh, as the world is pivoting to some of these other AI security kind of issues, that creates another unique space. In the same way that Monte Carlo started much more on the side of the, like, hey, you're downstream from all these engineers and everything, and you're about to get hammered by changes. You just don't have an observability layer for your basic data layer. So that starts you off. But what we've seen also is that the landscape has changed radically. Anomalo really was more for the engineers versus Monte Carlo being for the data scientists and the people at the data warehouse dashboarding layer. And now we're kind of realizing, wait, these worlds are kind of conflicting, all these different parts. And then, to where Definity also is there is like, man, now that like early days, if you saw a lot of Spark, that was not normal. Like Spark was like 4 to 6 sigma problem. Like you had to be really specialized, really good. Like you had to really want and need this. It's not for the faint of heart. But that layer has gotten easier to use through Databricks, more and more has kind of come up. And you're like, wow, okay, now we got these data pipes, we got the logic layer, we got all this stuff. Who's keeping an eye on this? And that's where stuff really kind of breaks. And so what I'm always looking for is, where's that really unique set of technical ideas that allow new product domains to really emerge? And I think it's also something that I always like is like, when a product just sells itself to the technical people where you don't have to fight them the whole way to help them understand, they're like, yes, that I could do that. I don't want to do that. You do that for me. Like that's when, and like I've been there plenty of times where I'm like, yes, I could totally do this. I'm like, do I want to do it? Hell no. Should I do it? Definitely not. Like that, then it makes it easy to have a vendor conversation.
So if I'll build on that and I bring it now a little bit closer to home, um, you talked about how Spark used to be like this very edge, sophisticated, or required some very deep expertise. Today, of course, I would say the Lakehouse in general and Spark oftentimes is kind of the foundation for it. Really became the kind of go-to architecture, especially in the world of data and AI all collapsing together. Of course, with an ML of traditional ML in the middle. On the other hand, so it's becoming so prevalent. Scale is the hyperscale mode. On the other hand, at the back end, while it's very, very easy to just spin up jobs and maybe spin up clusters and start doing some compute, the backend is still very, very hard. So you abstracted this whole layer of the lakehouse, but it's not less easy to run this infrastructure at meaningful scale with actual ability to do all of that. So maybe with all of that, can I segue into, with all of those great companies that you mentioned before, what prompted you and Great Point to be part of our journey?
Yeah. So I would say I've known Mate and the whole team since the beginning of Spark days. And so I've always been a huge fan of that. And I've also been super frustrated with it because I'm always like, man, this is so difficult. In my data shops, even up till recently, I haven't allowed kind of two layers of processing, so to speak. Like if you're doing it in a Spark Databricks-esque world, then I don't want you also to have it being done in the Snowflake-esque world, like because you're sitting like where is it the data? Do you do it as the data is moving, or are you doing it as on top of the data warehouse, the data lakehouse kind of situation? And the only reason for that, there's plenty of good reasons why that is. It's the same thing. Like, why don't you have like allow R and Python at the same time? It's because like if you have a small team, you can't manage across that very easily. It's just too much complexity. So you pick one or the other. I think it's very easy to pick on the data warehouse side, but the observation has been, wow, these data pipes are really picking up. There's a lot more of them. And what we see is there's more of them. Before it was like, oh, we might have a couple pipes just because we can't handle everything else through traditional ETL. Or we need something more specialized involved in there. And now then you look at it and you go, oh, wow, this thing is really taking off. Like there's a lot. And it's like you see this in all organizations. What people realize, like, oh, I could do that with this thing. Oh my gosh. Like, what about this? What about this? And it sort of unlocks a domino effect of innovation. And that creates this feedback cycle where you're like, do more, bring in more data, do more stuff, which is awesome. But then that means a lot more complexity. That means a lot more just management issues. That means like, how do I see stuff? Like, what's that observability tier? And all of that kind of falls apart. And then when you look at that and you go, is anybody doing that? Does Databricks support that? Not really. It's the same way like Snowflake doesn't support real great observability into your queries and what's happening. So you can't, you can't manage costs. And I think it's very easy to fall on top of like just get hung up only on the cost argument. But the thing that's more powerful to me is that there's a complexity thing that's coming. And I don't think people realize how big the complexity argument is going to get. Like like it's spaghetti times some exponential. Like that's coming with the AI stacks.
Yeah, so I think here we're coming kind of full circle to where we started the conversation. So I'll ask two questions that are essentially combined together. You mentioned some great broader observability infrastructure layers or specific companies that some of them are very focused or used to be focused very much on the data side. Some of them were much very focused on the infrastructure side. So question number one is, great. So even if you're on the Lakehouse ecosystem, that's harder and more complex, much more opportunity and configurations and power to you as an engineer. Obviously, with great power comes great responsibility. So much more area for mistake. Why are those data observability on the one hand and infrastructure observability, traditional monitoring on the other hand, why are they not good enough in the Lakehouse today? Question number one. Question number two, okay, so tomorrow, much more agentic workflows. I think Ali just mentioned more database code is now generated with AI than humans. What does it mean for observability tomorrow?
Yeah. So I think the first portion of that is like why haven't we seen more of this into the data lakehouse? And I think part of it is one, if you're a lakehouse or one of these ecosystem vendors, you don't really aren't incented to put it out there because
Okay.
it's like almost like this is why food companies don't want the caloric numbers on their food. You want just people to eat and eat more and more and more. You don't want them to know how much they're eating. They benefit on this. And that you've heard this all the time. Like somebody's like, wow, my Snowflake bill just came back off this one query and oh my gosh, what happened? You hear the same thing with Databricks. You're just like, this thing went across and like, what's going on? Why are we paying so much on this
No,
thing?
some analysts just spun up a cluster and they were,
Yeah, it just spun up something
forgot to turn it off, and he's like went on all night and
totally, and you just
30
don't
grand.
even. You're just like, it's a kind of the equivalent of like leaving your car running overnight, kind of thing. But the equivalent would be leaving your car on overnight while having a brick on the accelerator and it's in neutral. It's just like you're burning out everything. So and then on top of that, I think we're seeing a much rapid, like we're starting to see much more use of this data, and the lakehouse is being used in many more ways because of AI applications. So people are like, oh, if I have AI, I'm going to need all these other things. But even in a machine learning era, everyone's like, oh, if I got more stuff, more data, I got more products. People have kind of realized that flywheel is really there. So that demand cycle is there, but people aren't really incented to put it in. And then on the other side of it, it's a nice to have in markets where it's YOLO and you don't need to worry about cost structure and all those things. It's fine. You can totally do it. Right now, we're entering a phase of austerity on the data stack in many ways. And so you got to really kind of evaluate the costs, how you're managing it. And so that comes in. To your second question, to me, this is really a complexity question, which says, what's coming at us? On AI front, it's like, to your point, it's like, oh, more code is being created. We're seeing GitHub barely staying up. GitLab is suffering. Linear is suffering. Like the whole world around AI is not designed for the orders of magnitude that are coming at us. And so it's like, oh, okay, well, if I'm doing code review or I'm doing deployment, and can I absorb a 5x? I could definitely absorb probably a 3x. It's going to suck. 5x starting to get tough. 10x? I better have some real tooling, real infrastructure if I'm deploying pipes and new jobs and new stuff. 10x is hard. we're talking about 100 to 1,000x that may be coming at us. And so if you think about where the management and just organization and you know how much do you defragment your data pipe workflow, we have barely scratched the surface on any of that. But the beginning first portion of it is like, what do I have and what's going on? And and how do I manage that with the lowest, lightest weight kind of product? And that's what you guys have built is like, I can I can deploy it. I can check right now. It takes me 5 minutes and I can go see like, whoa, that happened. It's not going to take me like a 3 month POC to kind of evaluate it. That's the superpower and why I think anyone who's got any kind of Spark pipelines should be looking at Definity, because you're going to get hosed without it, especially in the AI. You're like, I would get ahead of that like yesterday. Because like the world that's coming at you on those data pipes is there, and you're not going to be able to, if you're in an organization, you don't get to really control data engineering anymore in that same way, because everyone's checking in their AI agent code, and so stuff is all over the place. So you may have stuff that's building full stack and doing all sorts of wacky stuff.
Yeah, and I think, look, if I distill kind of your past two answers, I think it comes down to actionability, and let me maybe break it down. In the world of Q1, Q2, 2026, data engineering teams, data platform, they want to be domain experts. They need to be domain experts. They want to be close to the business. They want to focus on what brings value to the business. Of course, to today is building much more into the UI, AI use cases. That means they want a lot of this back end type of work done for them. They don't want to go into more monitoring and more dashboard. They need actionability. And in order for that to happen, and the reason didn't happen in the past few years in the Lakehouse, maybe as well it was done in other platforms, other areas, that the complexity layers of the data stack, cost and infrastructure, and actual execution across multiple executors and lineage and code, and the environment itself and how it's configured on pipelines on top of that, and the data on top of that. You cannot just look at a specific layer. Hey, let's look at how many machines we are using and what's the provisioning, or hey, let's look at our data at the goal data. You need this full context, of course, another keyword these days, context, full stack, full data stack context, to now start reason and control and be able to drive actionability in the world of today for data engineering teams. And then in the world of tomorrow, to your point, one massive scale with agents that humans will not be able to handle on their own. So you need much more agentic capabilities, which, by the way, in turn will also increase your velocity as engineers, because you'll have agents. But those agents, we all wish it was that easy to just simply tell Claude or Gemini, hey, please do this for us. But if you don't have context, if you don't have control, if you don't have the right validation guardrails,
Oh, this is
teams will
going to
never be able to let them work in production systems on their own. So now it's a question again, how do you bring this context? How do you bring this control? How do you bring this validation? And you bring really good intrinsic native grasp within the system, within the lakehouse, across all of those layers to be able to do that. And again, we're seeing the really the teams that are pushing the envelope do that. I think we're seeing, teams that will try to still maintain dashboard and monitoring without the actionability element will just going to make it so much harder for themselves to, first of all, contain and maintain their infrastructure, and secondly, of course, push the organization forward with new AI and business use cases.
Yeah, that all lines up very well with what I'm seeing and what I expect. The one way to think of it is, for people who may be questioning that, is think about like, what was the traditional data warehouse? You had a bunch of very pristine tables. And then somebody's like, hey, I want more out of this data, more out of this thing. And then you're just like, end up with this really wide table. And then people are like, whoa, wow, this is not actually designed for this. Like, you got to do basically marts, or you kind of push the data in other ways. or you kind of redesign your tables. So all of that kind of has to happen. What you're starting to see now is AI, I think, is going to say the demand and the expectation of what the AI systems want out of this layer are so much greater. And so you're going to see the needs at the Spark layer grow massively. And the data lakehouse is going to get stressed in a way that we haven't seen, because you're going to push more, you're going to put more complexity in there, there's more demands. You're going to say, can the data lakehouse read at that level? Can it write back at that level? Like, you're kind of making this thing less of inside the data environment and more in a hybrid production environment. And that is going to that is a new paradigm at these scales and volumes. We've never done that before.
Yeah. So now if you think about kind of what's coming or already is here, actually, what are some of those platforms or teams missed today? Like they are all doing those AI demos and like, of course, like trying to bring them to production. But on the infrastructure side, do they have the right infrastructure to support it? Like what are they still missing? Where's the
Yeah. So I put this thing out. It's now kind of gone super viral from the White House time, which is like some of my product building principles. And one of them is, you prototype for 1x, you build for 10x, and then you
Mhm.
engineer for 100x. And so I think what we see right now happening with AI or data systems or data products in at the Spark layer many times is easy to get going at a 1x. And so you're like, one time, 1x the complexity, the volume, et cetera. It's easy to prototype. It's easy to do a hackathon with the data engineering level. And then you're like, oh, okay, now we need to really kind of like move from prototype to some more product. And you're like, can we really iterate this? Let's try it at 10x the scale. We're going to push a lot more through it. And you're like, wow, that's working. Early days of streaming. You're like, wow, okay, we can do this for a bunch of people. We can, we got this to work. And now you're like, oh, whoa, this is working. This is really working. Where, it's like, soon as the Super Bowl ends, everyone's like running with it to Netflix within 6 minutes, kind of thing. And then suddenly you're like, hey, is Netflix ready? Is it spun up? Is it got all those pieces? So you go, oh, that's at 100x or 1000x at scale kind of things. So I think we're still at the 1xer. We've got a few areas where it's the 10xers, the streaming environments, others. They're definitely at the 10xer kind of, or maybe even 100xer levels. But you're going to need to, as people move up this curve, or you have, say, 500 type of prototypes. In both examples, there's two axes, like volume or number of these kind of individual things, and then there's sort of like total like throughput or some other measure. And if you kind of end up, as you start moving on both of these directions, any one of those as well as both, then you're like, ooh, this is like, what's your management layer? And if something starts to go wrong, how do you debug? How do you figure out what's going on? This is really, really hard to figure out. Like it's really, really tough. This is my dog who's
Yeah, well,
he's
so we
he's like,
we
oh
we,
man, you're talking about data pipes. He's like, you need
we go
therapy.
beyond the barrier of language. You see, it's
Yeah, he's a
amazing.
therapy dog, kind of like for data pipes.
There you
Is
go.
his
There you go. Yeah, I think in recent and upcoming conferences, we see a lot of doggy petting zoo type of areas where I think
You need
people
it.
just
If you
need
work in
to.
this area, you need like it's so painful. It's like you like
We handle stress balls because we understand the
I know.
pressure.
I say,
So
like,
yeah.
trust me. I use my definity one. So next to my office, it's my office desk at work.
So maybe kind of if we have to wrap up with kind of final question, obviously someone who've been there for a long period of time, pioneered a few of those technologies, have seen the trends and where we are going. what's the kind of one thing that data executive, data platform, data engineering executives need to future-proof their platforms, their teams, their org as they're, in this rapidly changing world and where we're heading with agentic AI?
Yeah. I'm super empathetic to today's data leaders because it's really hard. The whole company is making giant bets on AI. And it's easy to say that. And you're like, well, how do you get the relevant data? How do you get the right things? And so, it's easy at the top level execs say AI strategy now. And then it's like supposed to magically happen. What I would tell everyone is you got to really be asking yourself, what are some of the key things that you need to get ahead of the curve and to be ready for that complexity? I would argue most data people who own the data pipes, those things, they're not prepared for even being able to answer it. And so what's going to
Mhm.
happen is very quickly stuff's going to start going sideways. And then there's going to be a whole bunch of questions and conversations that say, well, how much is it? You're going to be like, oh no, we need to run it for 3 months to get that answer. And you're like, yeah, really, that's exactly why we need to have it. Like, you want to start now on some of these things. And it is very easy to kind of be like, oh, I just don't want another vendor conversation. I don't want to think. So you want the lightest weight things that are possible where you don't have to do a strong POC. You just want to get going and seeing like, you know, um, um, how do you start getting a chance? And that's where I think observability kind of starts as a great place. So you get a sense of what's going on, and then you move from there to the management component of it. But you can't, to the Deming quote, which is, what does it's basically, if you measure, you only can manage what gets measured, and if we
Mhm.
don't measure it here, you don't know what's coming at you. So that would be the biggest one. And then probably if I had a second one, which is you're going to be asked to be doing more with less and a lot less and a lot more. And so how are you going to manage that? And what does that look like for that? And so getting some of those pieces in place now would be some of the biggest pieces of advice. Like, you want to do the easiest of hard things. And I think Definity, honestly, is the easiest of hard things to figure out how to get your head wrapped around these layers of this product, of the data pipeline product.
Nothing to add here, DJ. I think
Can I
again
steal your
you're in,
pitch?
yeah, exactly. So maybe from now on I'm gonna bring you in to chat with some folks. DJ, first of all, it's been fantastic chatting today. I really kind of love diving into your head. You obviously bring a tremendous amount of experience. It's been fantastic to partner with you and Gautam and the team at Great Point so far. You pushing us to be better and the partnership. So thank you for that.
This is like your polite way of saying stop being so annoying. Asking questions, saying, why can't we do this? Why can't
so
we do
so
that?
so anno- so annoying that I'm spending my Friday afternoon chatting with you on
Exactly.
record. No, it's been really a pleasure. If kind of for final thoughts, if folks want to follow you, where should they go?
Yeah. So easiest way is on LinkedIn. Although it's becoming a little more popular, I do have a photography site on Instagram at Patil. But otherwise, just do a search for DJ Patil on LinkedIn. That's the easiest. I'm on the other social media platforms, but not as active these days because it's kind of noisy and a little bit.
There you go,
It's like
Deepatil
data
on
pipes.
Instagram.
It's a little bit weird and a little bit unwieldy. And so until they get that under control, then maybe I'll be back there one day.
Amazing, DJ. Thank you so much. Have a great rest of your day.
Thank you. It's always fun.